Good day everyone, I am Ma'am Loy and I am going to discuss the second module for statistics and probability. For our second module entitled Solving Problems Involving Mean and Variance of Probability Distributions, we are going to discuss one of the activity in our module 2 from this subject. Example: two balls are drawn in succession without replacement from a jar containing 4 green balls and 3 orange balls. First question: what is the probability distribution for the number of green balls? And second, solve for the mean, variance, and standard deviation of the probability distribution. And as for our solution, let us bear in mind that we should first list the sample space for this experiment. Let G be a random variable whose values are the possible number of green balls that can be drawn from a jar, and let O be a random variable whose values are the possible number of orange balls that can be drawn from a jar. So from here, we have our sample space, which is GG, GO, OG, and OO. Since we are looking for the probability of the random variable G, we need to identify the number of G in each outcome. So we have a table representing the numerical representation of the occurrence of green balls. So we could have 2, 1, and 0. The frequency whereas 2 green balls will be drawn from a jar will be 1. 2, if 1 green ball is drawn from the jar, and 1 if there is none. So the total frequency is 4. Now we can identify the probability of each value of the random variable G and the probability distribution by dividing the frequency of each random variable to the total frequency. So the probability whereas 2 balls are taken from the jar would be 1/4. Next, 1 ball taken from the jar would be 1/2. And if none of the green balls will be taken from the jar, will be 1/4. And the total will give us 1. So this satisfies the condition given for the probability distribution, whereas the values of our probability should be from 0 to 1, and the total would be 1. So what is the value of the mean? So we use the formula, mu is equal to the sum of x times probability of x, whereas mu is equal to the mean, x is the number of x outcome, PR of x is the probability of the x outcome, and the sum of all x times its probability would be the summation of the product of x and its probability. To illustrate, we are going to use a table showing the product of an event and its probability. 2 times 1/4 will give us 1/2. 1 times 1/2 will give us 1/2. And 0 times 1/4 will give us 0. So the total will be 1, since 1/2 plus 1/2 plus 0 is equal to 1. This implies that if we are going to draw 2 balls from a jar, we are going to get an average of 1 green ball. Now, what is the value of the variance? We use the formula sigma squared is equal to the sum of the product of x squared and the probability of x minus mu squared, where sigma squared is equal to the variance, mu squared is equal to the square of the mean, x squared is equal to the square of the number of the outcome, and PR of x is equal to the probability of x outcome. For better illustration in getting the variance, we shall use a table whereas g squared and g squared times PR of g is shown. So for g squared, we would have 4, since 2 squared is equal to 4, then 1 squared is equal to 1, and 0 squared is equal to 0. Now, for g squared times the probability of g, we just simply multiply the g squared to PR of g. So we would have 4 times 1/4 will give us 1. 1 times 1/2 will give us 1/2. And lastly, 0 times 1/4 will give us 0. So we have a total of 1 and 1/2 or 1.5. And take note that 1.5 represents the sum of all the product of g squared and probability of g. So let us go back to the formula of the variance, whereas we do have sigma squared is equal to the sum of all x squared times the probability of x minus mu squared. So the sum of all x squared times the probability of x is 1.5, then minus mu squared, which is 1 squared, and that will give you 1.5 minus 1, and that is equal to 0.5. This implies that the distribution of the random variable g is narrowly concentrated around the mean since our variance is relatively small. And lastly, for the value of our standard deviation, we use the formula sigma is equal to the square root of sigma squared, where sigma stands for standard deviation and sigma squared stands for variance. Therefore, sigma is equal to the square root of 0.5, and that is approximately equal to 0.7071. It means that the spread of our data from the mean is around 0.7 units. That ends our example for Module 2, and I hope that you have learned something from this discussion. Have a nice day.